Okay, see Lindelof videos, finding a vertical asymptote. Let's call this a type 1 discontinuity, if you don't mind. There are different types of discontinuity, and I really want to get into talking about that a lot. One thing I want to say about discontinuity is that all holes are discontinuities, but all discontinuities are not holes, and that's going to make it's going to be a really important distinction to make here. What I want to make sure of first is that we don't have a hole in this function, and the way we're going to do that is to see if this is factorable. So I'm going to ask myself the question, is this factorable? And if it is factorable, do they share a factor? As I look at this thing kind of quickly, I see that this function is not factorable. And as soon as I determine that it's not factorable, then what I'm going to do is I'm going to take the denominator and set it equal to 0. So I'm going to say, okay, if I have x plus 7 equals 0. Now, of course, if you look at this for a second, if the denominator ever truly goes to 0, not if x goes to 0, but if the whole denominator goes to 0, the function becomes undefined. So there's an issue there. If the function is undefined, we have a discontinuity. So I'm going to solve this, and I'm going to say, when is x plus 7 equal to 0? Well, of course, that's true when x is equal to negative 7. This is a discontinuity. We know it's not a whole because it's not a removable factor. That is to say that x plus 7 is not a factor of this thing at the top, and therefore it can't be simplified out using algebra. So we have our vertical asymptote at the line x is equal to negative 7. And what that's saying to us is that this is what happens here, that at x equals negative 7, so we have this line right here. If this was a graph, we have this line right here. We have x is equal to negative 7. The function never passes through this line. So it's going to run up on the line and either push up against the line or push down against the line. And either on the other side, it's going to push up against the line and either go up, or it's going to push up against the line and go down. But it will not cross this line, right? That is to say, it will not pass through this line. All right, so I hope this was helpful. I want you to please keep in mind that there are different types of discontinuity. All holes are discontinuities, but not all discontinuities are holes. That is to say, a vertical asymptote is not a hole. A vertical asymptote is not a hole in the function. So I hope this was helpful. I'm going to go on and do one that actually is a hole in the function. So hopefully you'll look for that video. Thanks for watching. If you have any questions or comments, let me know. And if you haven't already subscribed, please subscribe. Thanks.